We have Mr. Sachin Gupta from Cisco up next. Thank you.
Hey, good morning, everyone. This is Sachin here from Cisco Singapore office, and thank you for your time. It's a pleasure to be here. I'm glad to be here and speaking on communications requirement for smart grid infrastructure. What we have today and where we are going, I mean, we all know utilities today are thriving for success, and operational efficiency is going to be a key in that success. How do we ensure whatever we spend today is going to be there for next 10 years or 15 years? How do we ensure whatever we spend today, can that be used for some other applications? For example, if we are spending today on an infrastructure for AMI, can I use that network for DA? Or can I use that network for some other applications? Right? Or when we spend something on substation automation, can we use that network for physical security? Can we use, how do we maximize our return on investment when we go on and invest something for next 10 years or 15 years of life cycle in utilities? And communications will play a very important role when you look at different use cases to add on. That's what I will discuss today. I always like to put this slide on the board. I assume some of you might have seen this before. But if you compare, if you put Graham Bell today and give him an iPhone, he would have no clue what is that about. And if you take Thomas Edison to one of the utilities or one of the substations, he will just feel, I'm right at home. So that's where the communication technologies have gone in the last 20 years or 30 years in the telecom world. And that's the revolution you can see in the utility applications going ahead. But what's happening today, I'd like to keep it short, but what's happening today, if you really see, typically utilities have so many silo networks, one for SCADA, one for teleprotection, one for AMI, one for DA, one for physical security, one for IT. And what we are doing is we are enabling chaos. It's totally chaos. You have no clue on security, how we are looking at security as a holistic view. We have no clue on where the networks, how the networks integrate, and eventually we are actually duplicating our investments, we are duplicating our efforts on everything, right? And that's where we are. And how do we invest in smart networks then? Where do we take it from here, right? So Cisco came out with Cisco Grid Blocks Reference Architecture. I know you can't see anything. It's Cisco typical, where they like to put something on the board. But actually, when we as a utility or when you go and plan to invest something on different use cases, right? It's critical to have some kind of reference model for communications. And typically, a reference model is a model which will give you an architecture. What are your requirements for communications, not for today, but for your next 10 to 15 years of requirements? If you see, this is a different, there are different layers. There are 11 tiers of communications. Each of that blue, each of this pipe actually represents one of the comms layer in different fields, starting from home area network, field area network, substation automation, data center, and back home. Thank you. And these are the communication requirements. What are your communication requirements? What are your bandwidth requirements? What are your delay requirements? For example, in substation, there are low latency applications, right? 4 milliseconds delay, 10 milliseconds delay for teleprotection. How do we achieve that? In AMI, we have different layers of bandwidth and security and delay requirements. At DA, we have another set of requirements. So before we invest or before we plan something to put together, it's critical to have some kind of reference model. And it's not about products here. We are not talking about products. It's more of your communication infrastructure, how you can look at security end to end, right? And when we talk about security, I know we have some very good sessions on security yesterday. It's not just one box of firewall in the substation. It's a very deep security architecture. Now we have standards like 62351 in IEC for substation security. And then how you look at broader picture of your investments from now till next 10 years or 15 years. Once you have that reference model, you will then look at different applications that you want to plan and add in next 5 years or next 10 years or 15 years of your deployments. You don't need them today, but can that infrastructure, whatever the communications infrastructure we will put it today, can that support the future investments? Can that support, for example, if you put something for AMI, how do we, I've seen some projects in Europe and other places where they went ahead with AMI and then later on realized when we want to add other use cases, the bandwidth is not available. Now we have to put, another infrastructure there to have other applications. And that's again, duplication of efforts, duplication of investments. So when we look at this architecture, look at your applications, build different use cases between architectures for each individual use case or requirements. When I say use cases, basically it's a Cisco term again, where we test those applications for bandwidth, delay, and latency requirements, and we say this is the right network required for that particular application. And what Cisco has today, we just entered, we were on the IT space previously on telecommunications and financial sectors. Recently we have a new BU focused on smart grid and utilities, and we are looking at end-to-end solutions from AMI all the way back to the data centers. And 3 things which we are focusing on is open standards, multi-service architecture, and security. And when I say multi-service architecture, it's the same thing that, how we can enable devices to be used for multiple applications. So currently for field area network, we have deployments in US, and now we recently won a project with CLP in Hong Kong with Itron, and where the same box which was used for AMI can also be used for DA and other applications. We also recently announced our partnership with Alstom for substation automation, and we are looking forward to grow in the India market as well. Again, security, I will not touch that. We already had that topic yesterday, but it's a very, I can speak hours on this topic. It's a very comprehensive design to look at how you look at 62351 deployments and get deep design in security when you look at your architectures. When we speak to utilities worldwide, right, those are the 6 concerns typically they will always have. How do we manage CAPEX versus OPEX communication networks? How do we have 3G or whether I have my own personal network? So those are the typical questions you will see. At the same time, you will also see how do we achieve interoperability across standards? Whether are we going to commit with a proprietary network and stuck with them for life, or whether we invest on something open standards and where you can change and things with multiple vendors and things. Third thing is grid modernization or smart. We also use the word grid modernization. Pretty much what we saw yesterday is it's not going to happen overnight. It will be 5, 6, 10 years life cycle where you will see progress on different things. But when we are progressing, what do we do with our legacy equipments? Are we going to throw them away, or when we invest on something, is the same infrastructure capable of supporting legacy equipments or legacy protocols? What are we going to do with 101 devices, or what are we going to do with different legacy protocols which are already there in the substation? So when we came out with our products, so we are looking at products which can support future technologies, but also have serial supports for Modbus and in your typical SCADA interfaces. Implemented pervasive network security, that's another critical topic that we always see worldwide, what's happening there and how can we look at these things. Network management, another thing, a lot of people do not consider this in the initial requirements, but if you scale to 2 million, 3 million, 4 million, 10 million households, network management is a key thing. I have a video on this if time permits. I'll later show on. Sure, okay. How does network management is looked at. And then managing complexity of technology transition. How do we move, enable, from SDH to MPLS networks, or how do we move from, traditional networks like telemetry to more advanced networks when we have AMI and DA combined applications, right? one of the things, I was recently reading a magazine, and there was a very nice joke on smart grid, which said we had to burn all our trees to create more, to print more currency for our slump economy, to create, green jobs in our country, and that's what everyone is running after, right? We are missing the point, that whether do we really need that application. If we need that application, what kind of communications architecture is required? And if we invest in communication architecture, can that be also be supported for other applications, what we add in future or 5 years or 10 years time? So that's what I have for today. When we plan, or when utilities look into investing something, it's very important to look at communication architecture beyond what you have today, build the network, and run the connected grid. So with that, thank you very much, and if time permits, we can always look at the video later on. I would like to thank ISGF and Mr. Reggie inviting me here. It's a pleasure to be here, and thank you again. Pleasure.
Thank you, sir.